Alrighty, so here we go. You should have your notes out. 5B, overlapping triangles. So as I record, you should be stopping and listening. That's the beauty of listening to a recording for notes. If you don't get something, you can stop it and pause it, or you can go back and listen to it again, just to make sure you understand. Alright, diagrams often show overlapping triangles. It's usually helpful to separate. It's not just usually, it's very helpful to separate the triangles in order to study them. So for example, here we have two overlapping triangles that I see. I see this and this. So I'm going to split them apart as best I can. I'm going to start with this one. Just kind of draw it sort of like it looks there. And I'm going to label it the same letters, A, B, E. And then I'm going to draw this one over here. And I'm going to label it the same letters that it has there. Okay? That's what I mean by separate. And then you can start labeling congruent parts and so on. It's a little easier that way. Alright, sketch the overlapping triangles separately. Mark them with their congruent parts, then tell what theorem or postulate you can use to show that the triangles are congruent. Alright, so I see a triangle here, so I'm going to draw that. And that's B, P, J. And then I'm going to draw this triangle right here. I like to draw them sort of in the same direction that they were. So here's P, and I'm going to mark up what was given to me in the drawing. Okay? This is, I've got to put K, J, B. And K had a single line on it, which means it's congruent with P. And J had a double. But I can't do that because it's only part of it's only this part of J. But I can do B, which makes sense if you look at it. Now the other thing I have to do is I have to just take a minute and look at my drawing again and say, is there any other part that they actually share, which means that they have congruent in common? And look, BJ is congruent to itself, so that means in these pictures those sides are congruent as well. Alright, what theorem or postulate would we use to show that they're congruent? So if you just look at this one here, we have angle, angle, side. Angle, angle, side is what we would use. Okay? In the following figure, I think what I'm going to do first is I'm going to split it up. And then I'm going to mark what they tell me here. It might be easier. So I'm going to draw this triangle first. So I'm going to do N like this, just kind of however close you can do it. That's K, R, M. And then I'm going to draw this triangle right here. Hold on a minute. That's much better. I don't know why it got dark all of a sudden, but it did. And then I'm going to draw the second triangle and label it R, T, Q. So I separated them. Up here it says angle MKR. MKR is congruent to angle QTR. Okay, I'm going to mark that. And segment TR is congruent to segment KR. And if you look in the picture here, you see angle R here? Well, no matter what, if I put it in the first triangle or if I put it in the second triangle, it's still going to be congruent to itself. So I can mark that as well. All right? Now I can say RMK is congruent to RQT because of angle, side, angle. All right, let's keep going. In the following figure, angle GBO and angle HOB are right angles, and BG is equal to 15 and OH is equal to 15. So let's just kind of split them up first. I'm going to do that. Well, they don't look very even, but I'm going to assume that they are. So this is G, B, O, and this is, let's see, H, O, B. Okay, This says that angle GBO is a right angle, so I'm going to mark that there. And angle HOB is a right angle, so I'm going to mark that there. And BG and OH are both 15. So BG and OH are 15, which means that they're congruent. And then if I look just real quick again at the picture here, I see BO and BO. It's a side that both the triangles have in common, which means BO is congruent to BO. All right, so let's look at this now. What could I use to prove that they're congruent? I could use side, angle, side. I can't use hypotenuse, leg in this one because I don't have that the hypotenuse is congruent. So, side, angle, side. And I'm going to say the triangle BGO is congruent to, I started with the right angle and I went over on the single side, so I'm going to say OHB. Triangle OHB. Okay, here's another one that we have to separate and how we would see that they're congruent. So I want to make sure they're still talking about the big triangles. They are TPC is congruent to RCP, yes. So let's look at this real quick. I see that they share PC in common, so I'm going to say that this is congruent to itself. But for now, I just want to kind of split it up. So I'm going to split up. I'm going to write the first triangle like this. And then this other triangle here, I'm going to label this TCP. That's this triangle right here. And I can mark that that's there, and the double lines are here. And then I'm going to draw the other one next to it, sort of in the same direction. And that's RCP. And I can say there's a squiggly there on R, and there's the double one here on P. And then I know that they share this side PC, so it's going to be congruent to itself. Okay? And so we can see by looking at one of the triangles that we have angle, angle, side. That's how come they're congruent. And we made sure we did this. State why the triangle is congruent to itself. Oh, let's put the little triangle sign in there. Sorry, that's missing. Alrighty? Okay, another one. State why triangle PAT is congruent to triangle CAR. So let's look. We have PAT, I'm working with that, is congruent to CAR. Interesting. Okay. Before I split it up, I'm just going to look at this picture and see what I can do. First of all, I see here that I have vertical angles. Angles are made by two intersecting lines. So I have vertical angles, so I'm going to mark 3 there. Those angles are congruent. I'm going to need something else. So I got to look and see what I have here. I can't see anything here. I can't see anything here. But if I look at that bottom triangle, I see that the angles are congruent on the base, which means that it's an isosceles triangle. Oh, pretty nifty. That tells me that the sides opposite those congruent angles in an isosceles triangle are going to be congruent. So I can put a mark here and a mark here. Alright, now I'm going to split them up and draw them. Actually, I really don't need to split them up. If you can see it without splitting them up because they're not really overlapping, then you don't need to really redraw them. But since we've marked it up, let's cover one up and see what we would use. We would use angle, angle, side. Remember, the things that you're talking about have to be consecutive here. Angle, angle, side. That's what I would use to prove that they're congruent. We have vertical angles, and we're using the base angle theorem on isosceles triangle. All right. State why TPC is congruent to RCP after separating and labeling them. All right, I'm going to go ahead and separate them then. TPC and RCP. And RCP. Okay, there's a right angle here for P, and there's a right angle at C. And then they showed me that TP is congruent to RC. And I see here, since I'm talking about this triangle and this triangle, they share this side in common. So PC is congruent to PC. Now that I've marked it up, I can see that I have side, angle, side. Alrighty, let's do another one. And then, of course, we have to write a couple proofs. So, they want to know, are triangle ABC and triangle EFC congruent? So I have ABC and EFC. They want to know if this triangle is congruent to this triangle. That's what I'm looking at here. Okay? I may not need to separate these. Let's just take a look. So they both have a right angle and they have a leg. Right angle tells me they're right triangles. They have a congruent leg. If I can prove that the hypotenuses are congruent, then I can say they're congruent. And look what I have here in this triangle. I have an isosceles triangle. If their base angles are congruent, that means that their opposite sides are also congruent. So this is congruent to this. Now if I look at one of these right triangles, I can say that those two triangles are congruent by the hypotenuse leg theorem. So that's what I would use. They're right triangles, so I can use the hypotenuse leg theorem to prove that they're true. Isn't that cool? All right, turn the page. Let's do a couple of proofs, and then you're done. All right, so it says complete the proof. Well, just to make it a little easier, I am going to split up my drawing right now. So this is this triangle here. This is D, B, E. And then I'm going to do this triangle right here. B, C, A. And then let's see what they gave me. They told me that segment AB is congruent to segment EB, okay? And segment BD is congruent to segment BC. I don't have enough information. Let's go back and look at my picture. I see here that they share angle B. Both the triangles share angle B, so angle B is congruent to itself. Okay, so now I can use side angle side. Sweet. So the first thing, of course, I'm going to do is write down the givens. So I'm going to prove, let's see, AB is congruent to EB, that was given. BD is congruent to BC, that's a given. Okay, so let's see what I need. Oh my goodness, if I'm doing side angle side, and I need to prove that AB is congruent to BE, they already gave that to me, so I've already done the side. Now let's look at the angle. Okay, I'm going to talk about angle B. Well, angle B here is congruent to itself, so I'm going to say angle B, oh, not A, angle B is congruent to angle B. That's reflexive. So I've done this other side, I've done the angle, and then I need to do BC is congruent to BD. Well, they already gave that to me, so I've already proven that. So it's a pretty short proof. Therefore, I can say, oh, there's supposed to be little triangle things here, you guys. I can say triangle ABC is congruent to triangle EBD because of side angle side. Short and sweet. All right, last one. Let's see what we have here. Let's split this up. I need to prove that angle PQS is congruent to angle STP. Okay, so instead of actually writing out the proof, I just want you to split up the picture and let's mark them both up with what we know is congruent. So I'm going to say this is QSP and TSP. They told me that angle Q and angle T are right angles, so I'm going to mark those. Okay? And then they said that QP is congruent to TS. Okay, so I know that. I'm going to need one more thing here. So I'm going to look back at the drawing and see if they share anything in common. And they do share this side right here, PS, PS. PS is congruent to itself. Okay. Well, if I cover up one triangle, I notice that I have angle side side. Can't use that. However, it is a right triangle, so I can use hypotenuse leg. That is what I would use to prove that the triangles are congruent. And then you would write out the proof. Okie dokie? Now, when you get started on the homework, which is the rest of this here, there's some that I want you to take out, okay? Let me just find out what they are here. You don't need to do B. You don't need to do 3B. And you don't need to do number 4. And you're going to like this. Are you ready? You don't need to do the proof. I don't need to do that proof. I just want you to practice the overlapping. Alrighty? That's it, folks.